You know, some elements on the periodic table tell a story that goes way beyond chemistry, a story of struggle, of national identity, and of pure defiance. Today, we're diving into one of those, element 84, polonium.
Okay, so let's set the scene. It's the end of the 19th century, and Marie and Pierre Curie are looking at a real head-scratcher. They're studying this uranium ore called pitchblende, and they notice something that just doesn't make any sense. The raw rock was way more radioactive than the pure uranium they pulled out of it. Something was definitely off.
Now, this wasn't just some small measurement error. This was a massive clue. It was practically screaming that something else was hidden inside that pitchblende. Some undiscovered element, way more powerful than uranium, was just lurking in the leftovers. The hunt was on. So, to solve this puzzle, Marie Curie basically had to invent a whole new field of science, radiochemistry. The genius of it was using the very thing she was looking for, radioactivity, as her guide. After every chemical step, she'd measure which part was more radioactive. She was, in essence, just following the glow, letting the element itself show her the way.
But this wasn't just some neat intellectual puzzle solved on a chalkboard. No, it required an absolutely staggering amount of physical work. The story of this discovery moves from the clean pages of a notebook right into the dirt and grime of a lab that was, well, let's just say it was less than ideal.
Their lab was what one visitor called a miserable old shed. It was a former dissecting room that leaked when it rained and had almost no ventilation. I mean, can you imagine? Spending your days stirring these giant, boiling cauldrons of chemicals with all these toxic fumes filling the air? That was the gritty reality behind one of the greatest breakthroughs in the history of science.
Please remember to subscribe to our channel and turn on the notification bell, share and like our videos. The information in the video is compiled from open sources. Thank you. So their process was just relentless. It was so systematic. They take the pitchblende, run it through a chemical separation, and then measure every single piece. They'd peep the most radioactive part, toss the rest, and then just do it all over again and again and again, painstakingly narrowing it down.
And the scale of this whole operation was just immense. They weren't working with a few grams in a test tube. The Austrian government basically gave them several tons of radioactive waste from their mines, and the Curies just got to work processing every last bit of it.
This wasn't a quick find, not by a long shot. The whole process of separating, measuring, and refining all that raw material took about 4 years. 4 years of grueling, backbreaking labor.
And after all that, what did they have to show for it? Well, by 1910, Marie Curie and her colleague André de Beauharnais finally managed to isolate a tangible amount of the stuff. After processing tons of ore over years of work, they produced just 1/10 of a gram. But this discovery was about so much more than just a new substance on the periodic table. To really get why, we have to look at the world map the way Marie Curie saw it, and we have to notice what was missing.
You see, in 1898, Marie Curie's homeland, Poland, didn't exist as an independent country. It had been carved up and swallowed by Russia, Prussia, and Austria. Her own home city of Warsaw was under the thumb of the Russian Empire, which was pushing these harsh Russification policies designed to completely erase Polish culture, its language, its entire identity.
And then, on July 18, 1898, the Curies submitted a paper to the Academy of Sciences. They announced they'd found a new metal, a lot like bismuth, but intensely radioactive. And then came the name.
With that single sentence, Marie Curie turned a scientific paper into a political manifesto. This was the first time in history an element was named to put a spotlight on a political crisis. She was using the global stage of science to force the entire world to remember a nation that had been literally wiped off the map.
But just naming it was one thing. Getting the scientific community to actually accept it, that was a whole other battle. The element's existence and its very political name faced a ton of skepticism. It was a real fight for its place on the periodic table.
Oh yeah, the fight for the name was just getting started. Because polonium was so hard to isolate, other really respected scientists were finding its isotopes independently. And, not knowing it was the same element, they gave it their own names. A prominent German chemist, Willy Markwald, was sure he'd found something new he called radiotellurium. The legendary Ernest Rutherford called it radium F. For a while there, it really looked like the curious claim and their defiant name could just get lost in all the confusion.
It took years of arguing and debate, but finally, by 1905, the scientific community came to a consensus. All these different discoveries were just isotopes of one single element. And then, a year later, Willy Markwald, to his credit, graciously conceded that the Curie's name came first, and he proposed that polonium be the official name from then on. Marie's defiant name had won.
Think about that. At a time when her country had no political voice, when it was physically gone from world maps, she gave it a permanent, unerasable place in the universal language of science. It was etched forever into the very fabric of the universe.
It really makes you wonder, doesn't it? We often think of science as this cold, objective collection of facts. But the story of polonium shows us that it's also a deeply human document, written with passion, dedication, and sometimes as a profound act of protest. What other hidden human stories are out there, just waiting to be told in the language of science?